2 missiles, 47 seconds, $340 million. That is the arithmetic of what happened over occupied Crimea on the night of September 9, 2023, at precisely 2:14 in the morning. The mathematics are clean. The story beneath them is not. It begins 11 days earlier, in a windowless operations room inside a Ukrainian military facility, whose location remains classified to this day. A targeting officer named Major Oleksiy Kravchenko is staring at satellite photographs that arrived overnight from a Maxar Technologies imagery pass over the Crimean peninsula. He has been running targeting operations for the 19th Missile Brigade for 8 months. He has reviewed hundreds of satellite imagery packages in that time. This one is different. In the latest images, 2 Pantsir-S2 air defense systems that were previously positioned at standard dispersal points around the Saky airbase perimeter have moved. They have not moved to new dispersal positions across the base. They have moved toward each other. A cluster where doctrine demands separation. This is not normal, and Kravchenko knows it. What Kravchenko did not yet know was that the intelligence cycle he was about to initiate would end. 47 seconds of detonation that fundamentally rewrote Russian air defense doctrine across an entire peninsula. He did not know that a partisan network in occupied Crimea would go dark for 40 hours at the most critical moment of that cycle. He did not know that the crew of a Russian Pantsir battery would launch their interceptors in the final 31 seconds before impact and fail. And he did not know that the corridor his strike would open would remain exploitable for 9 days, instead of the 72 hours he had planned. 4. He knew only one thing on the morning of September 1, 2023. Something was coming to Saky. Saky Air Base occupies the western coast of the Crimean Peninsula, approximately 40 kilometers northeast of the city of Yevpatoria and 48 kilometers west of Sevastopol. The base was built in the 1950s as a Soviet naval air station designed to support Black Sea Fleet aviation operations during the Cold War. Its runway complex, capable of handling aircraft up to the Tu-22 M3 strategic bomber class, made it one of the peninsula's most strategically significant installations. During Soviet times, Russia seized Saky during the initial occupation of Crimea in March 2014. In the months that followed, the Russian Aerospace Forces began expanding its infrastructure and converting it from a maintenance-degraded Soviet legacy base to an operational, frontline installation. By 2018, 2 Su-30SM multi-role fighter squadrons were permanently assigned. By February 2022, when Russia launched its full-scale invasion of Ukraine, Saky had become the western anchor of Russia's Crimean air power projection capability. The aircraft based at Saky carried weapons that defined Russian operational reach in multiple dimensions. The Kh-31P anti-radiation missile, carried by Su-30SM aircraft at Saky, was designed specifically to target and destroy ground-based radar systems. Ukrainian air defense radar operators knew that a flight of Su-30SMs from Saky could appear over the front line with less than 16 minutes of warning time and destroy the radar infrastructure that protected Ukrainian ground forces and cities. The Kh-35 anti-ship missiles stored at Saky were a persistent existential threat to any Ukrainian naval presence in the western Black Sea. The Su-30SM's multi-role capability meant each aircraft could prosecute either mission depending on payload. Russia considered Saky untouchable, and for 18 months of the full-scale war, it was. The base's perimeter air defense architecture was designed to reflect that confidence. 4 Pantsir-S2 systems occupied the cardinal approach points around the base perimeter, one at each compass position. Behind them, S-400 Triumph long-range surface-to-air missile batteries, positioned around Sevastopol and at inland nodes, provided strategic-level coverage extending 400 kilometers in every direction. An A-50U airborne early warning aircraft typically orbited over the Black Sea on regular rotations, providing elevated radar coverage to fill detection gaps in the ground-based network. The theory was straightforward. Anything trying to reach Saky from a long range had to survive the S-400 engagement envelope. Anything that survived that and tried to approach low had to survive the Pantsir systems. Nothing could survive both. The theory was constructed around a threat set that did not include what was about to arrive. On September 1, 2023, Kravchenko's Maxar imagery showed that 2 of the 4 Pantsir-S2 systems had repositioned from their standard dispersal points to the southwestern perimeter of the base. They were now within approximately 200 meters of each other. Combined with the Pantsir system that had been permanently stationed at the southwestern approach, this created a three-system cluster in a single defensive zone. The fourth system had moved to cover the northern approach, leaving the eastern and southern perimeters with reduced organic coverage. Kravchenko had seen this pattern before, in different contexts. When a Russian installation was expecting a high-value transfer or a high-priority deployment, the local command would sometimes temporarily concentrate air defense assets around the expected arrival vector. It was operationally rational. It was also doctrinally risky, because concentration meant that a single precision strike could degrade multiple systems simultaneously. Russian doctrine specifically warned against it, which meant whoever had authorized this clustering had weighed that risk and decided it was acceptable. That required a level of confidence in the overall defensive umbrella, or a timeline pressure that overrode standard doctrine, or both. Either way, Kravchenko had a window. He called his intelligence liaison at 6:47 a.m. He filed an intelligence tasking request. He needed HUMINT confirmation of the target cluster's status and any available indication of what incoming asset was prompting the concentration. The partisan network operating in western Crimea at this point in the war was not large. After 9 years of Russian occupation, active resistance cells had been reduced through FSB pressure, arrests, and the general attrition of irregular intelligence operations in a territory where the occupying power had had nearly a decade to build counterintelligence infrastructure. The FSB's presence in Crimea was significant and active. Surveillance sweeps of known or suspected sympathizers were routine. Digital communications were monitored with increasing sophistication. Physical surveillance of anyone with connections to pre-2014 Ukrainian civil society was persistent. The cell that received Kravchenko's tasking request operated under a single codename, Berkut, Falcon. Berkut's 4 active members, whose identities remain classified and will not be disclosed here, had been operating in western Crimea for approximately 3 years by September 2023. They used encrypted messaging relays, dead-drop communication protocols, and strict operational security disciplines developed through years of close calls and near compromises. Their transmissions to Ukrainian military contacts across the contact line were infrequent, brief, and specific. Every transmission was a calculated risk. Every observation they made near a military installation was conducted under surveillance threat conditions that most people in this war will never experience. The FSB did not arrest suspected intelligence assets in occupied Crimea with the same procedural consistency as conventional law enforcement. Being identified as a Ukrainian intelligence asset in occupied Crimea meant one of two things: detention in conditions that violated every applicable standard of international law, or disappearance. Sometimes followed, weeks later, by confirmation in leaked detention records. Berkut operated in that environment every day for years. One detail that stuck with me when reviewing the declassified targeting documentation was the operational specificity of what Berkut was asked to provide. Kravchenko's tasking request was not a general surveillance request. It was a precision intelligence requirement. Specific coordinates, specific platform identifications, specific information about the antenna configuration of a radar unit visible in satellite imagery. This was not the kind of tasking you give a network with limited capability. This was the kind of tasking you give a network you trust with a strike package. Berkut delivered. On September 3, 2023, Berkut transmitted its first observation, a ground-level photograph taken at range through a concealed telephoto lens through a gap in the ATACMS. Vegetation lining the southwestern access road showed 2 Pantsir-S2 launch vehicles parked within approximately 200 meters of each other. Both vehicles had their radar antennas in active monitoring posture. Operational, waiting, a detail that did not appear in any of the initial public reporting on the Saky strike. The 2 Pantsir-S2 systems in the Berkut photograph were not identical configurations. One was a standard S-2 launch vehicle with the Pantsir's organic 1RS-21E fire control radar. The other showed the additional antenna assembly associated with the 96L6E standalone long-range acquisition radar. The 96L6E is not an integral part of the standard Pantsir-S2 platform. It is a separate system, mounted on its own KAMAZ 6350 vehicle. that extends a Pantsir battery's target detection range from the organic 20-kilometer envelope out to approximately 300 kilometers. It can track up to 100 targets simultaneously and feed that tracking data to multiple Pantsir fire control systems simultaneously. Deploying a 96L6E at Saky's southwestern cluster was not a routine enhancement. The 96L6E acquisition radar had a unit replacement cost of approximately $82 million. 2 units valued at $82 million each had been assigned to the southwestern cluster. Someone had sent their most capable radar assets to Saky's most concentrated defensive position. Whatever was expected at Saky was important enough to warrant it. On September 5, 2023, Burkett transmitted its second observation. A new vehicle had arrived at the southwestern cluster, not a Pantsir, a modified KMAS 6560 truck with an expanded communications array and a satellite uplink dome mounted on its cargo bed, battery-level command post signature, mobile coordination hub, designed for a Pantsir battery commander to manage multiple systems simultaneously, integrate external radar feeds, and coordinate with the S-400 batteries and Air Force command structures above him. Someone had just established a forward command node at Saky's most heavily protected defensive position. This was preparation, sustained preparation, not for a transit through Saky but for operations launched from Saky and protected by Saky. On September 6th, a satellite imagery pass captured 3 fuel transfer vehicles moving fuel from the main Saky aviation fuel depot on the northeastern perimeter to a secondary storage point adjacent to the southwestern Pantsir cluster. The transfer took approximately 4 hours. When it was complete, the secondary storage point held an estimated 340,000 liters of aviation fuel in a configuration, indicating sustained operational use rather than emergency reserve. 340,000 liters, an operational fuel reserve, in proximity to the most heavily defended position on the western perimeter of a base hosting 2 Su-30 SM squadrons. Kravchenko now had 3 corroborating intelligence threads, all pointing at the same conclusion. Something was coming to Saky. The arrival was expected soon. The southwestern cluster had been configured to protect it. He built his preliminary targeting package on September 7th, 4 primary aim points, the 2 clustered Pantsir-S2 launch vehicles, the mobile command post positioned between them, the fuel depot secondary storage point 200 meters north. He also files a formal request through established liaison channels for NATO ISR support to complete the targeting solution. The request was approved within 6 hours. The nature of that ISR support, which specific assets, what platform altitudes, what sensors, what analysis methodologies, remains classified at a level above what has been formally released. What the declassified summary states is that the targeting cell received additional high-resolution intelligence, enabling them to complete precision, aim-point calculations for all 4 targets simultaneously. What the results tell us is more specific than the documents acknowledge. The first ATACMS missile's aim point was calibrated to place the fragmentation pattern of a 227-kilogram warhead in a position achieving simultaneous mission kill on both Pantsir launch vehicles, both 96L6E radar units, and the command post. This required knowledge of the exact position and structural vulnerability of 5 separate assets, including the orientation of radar antennas and the specific fragmentation distribution of the warhead at a defined detonation altitude. Satellite imagery can tell you where a vehicle is parked. It cannot tell you where a radar antenna is pointing, or what structural failure modes a specific warhead creates at a specific burst height. That information came from the ISR package. By evening of September 7th, Kravchenko had a completed targeting solution, a 2-missile strike package, a 48-hour launch window, conditioned on weather, and 1 final HUMINT confirmation from Burkut. The confirmation never came when expected. At 11:30 p.m. on September 7th, 2023, Burkut went dark. No transmission, no acknowledgement, no signal. In partisan intelligence network operations, radio silence is not automatically a crisis indicator. Cells routinely suspend contact during FSB sweep periods, technical failures, equipment compromise, or surveillance avoidance. Burkut had gone dark before, for periods of 12 to 20 hours, without incident. But this timing was existential. Without a final confirmation that the target cluster had not moved since Burkut's September 5th observation, the strike package could not proceed to authorization. if the Pantsir systems had repositioned in the previous 48 hours, and Kravchenko fired. On their last known coordinates, 2 ATACMS missiles would hit empty parking areas, while active air defense systems remained fully operational at a different location. The window was running. Kravchenko's targeting cell maintained operational posture through September 8th without Berkut contact. They ran contingency scenarios. They reviewed alternative approach trajectories. They modeled what a repositioned cluster might look like if the systems had dispersed back to their standard deployment points. None of it mattered without confirmation. 12 hours of silence, 24 hours. 30. If Berkut did not confirm by 10 p.m. on September 8th, the atmospheric conditions that defined the planned approach trajectory would close. The next comparable window was 10 to 14 days out. In 10 to 14 days, the high-value asset that had prompted the Pantsir concentration might have arrived and departed. The cluster might have dispersed. The window that Kravchenko had 11 days of intelligence to open might close without ever being used. 40 hours of silence. At 9:14 p.m. on September 8, 2023, Berkut transmitted one message: compact, verified. The target cluster was intact. Both Pantsir systems at their established positions, command post unmoved, fuel reserve undisturbed, and one additional element that Berkut had risked an extra observation run to collect. During the day of September 8th, a maintenance crew had been working on one of the 96 L6E acquisition radars in the southwestern cluster. Long-range observation showed the crew completing a recalibration sequence, standard visual indicators, antenna adjustment runs, signal test positions, the specific standing configurations that radar operators assume during post-maintenance verification. The crew had finished and departed at approximately 6:06 p.m. on September 8th. A freshly calibrated 96 L6E meant the system was being prepared for sustained high-intensity operation, not standby, active operation, intensive enough to justify a maintenance recalibration immediately beforehand. Whatever was expected at Saky was expected within hours, not days. Kravchenko submitted his strike authorization request at 9:31 p.m. It was approved at 11:47 p.m. The 19th Missile Brigade received its launch window. 2:00 a.m. to 2:30 a.m., September 9, 2023. The missiles were prepared. The targeting package was finalized. Berkut had confirmed. Everything was in place. What the targeting cell could not know was what the Pantsir crew on duty at the southwestern cluster was doing at 1:47 a.m. Whether they were alert, whether they were experienced, whether the crew that had watched the September 8th maintenance team recalibrate their radar was the same crew that would be on shift when it mattered, what the crew's reaction time would be, what their final transmission would say. The MGM-140 Army Tactical Missile System began its development in the 1980s as a United States Army requirement for a precision long-range surface-to-surface weapon capable of striking targets deep behind Soviet lines. Lockheed Martin won the development contract. The system entered service in 1991. The M39 variant, which uses a unitary 227-kilogram high-explosive warhead rather than the submunition variants that the United States retired from. Its inventory has a range of approximately 165 kilometers from a standard M270 or M142 launcher. Its guidance system combines inertial navigation with GPS terminal corrections. The circular error probable, the statistical measure of aim point accuracy, is approximately 9 meters. That figure is not the maximum miss distance. It is the radius within which half of all rounds will impact. The other half may land slightly further from the aim point. A Pantsir-S2 system occupies a vehicle footprint approximately 12 meters long and 6 meters wide. The crew positions are within the vehicle. There is no external shelter. There is no separation between the system and the people operating it. 9 meters, up against a 12 by 6 meter target. The math of precision warfare requires no additional commentary. For the Saky strike package, the 19th Missile Brigade had designed a deliberate sequencing. The first missile was assigned to the southwestern cluster. Its aim point was calibrated not to hit either Pantsir vehicle directly, but to position the 227-kilogram warhead's fragmentation envelope to achieve simultaneous mission kill on both Pantsir launch vehicles. Both 96 L6E radar units positioned 90 meters apart on the outer edge of the fire control zone and the command post vehicle parked between the Pantsir launch platforms. 5 targets, 1 aim point. The calculations required millimeter precision knowledge of vehicle positions, antenna orientations, warhead fragmentation angles, and detonation altitude. This is what the NATO ISR package enabled. The second missiles was aimed at the center of the fuel depot secondary storage point. At 1:47 a.m. on September 9, 2023, the 19th Missile Brigade launched. Two MGM-140 ATACMS missiles left their launch platforms from a position in mainland Ukraine, whose exact location remains classified, and began their ballistic trajectories south-southeast over the Black Sea coastline. Flight time to Saky Air Base, approximately 6 minutes and 27 seconds. At 1:53 a.m. and 40 seconds, Russian air defense radar at Saky detected two incoming tracks. Track parameters were immediately consistent with ballistic smell inbound. The fire control system at the first Pantsir in the southwestern cluster received the alert automatically. The crew's targeting display lit up. The crew on duty had 31 seconds. Understanding what 31 seconds means operationally requires understanding what the Pantsir engagement sequence actually looks like. A trained Pantsir-S2 crew, to engage an incoming ballistic target, must execute a defined sequence. The fire control computer generates an initial tracking solution automatically upon target designation. The crew confirms the track classification as hostile. The crew initiates firing solution computation. The fire control system verifies intercept geometry. The crew authorizes launch. The launch command is executed. Two 57E6 surface-to-air missiles exit their launch tubes and begin their intercept trajectory. From initial track confirmation to missiles away, a trained crew under optimal conditions can complete this sequence in approximately 18 to 22 seconds. The Pantsir crew at the southwestern cluster performed within those parameters. At 1:54 a.m. and 11 seconds, they launched two 57E6 interceptors. The 57E6 missile has a maximum engagement speed against an incoming target of approximately 1,000 meters per second. The ATACMS in its terminal phase was traveling at approximately 1,600 meters per second. The two 57E6 interceptors missed. At 2 a.m. and 14 seconds, the first ATACMS warhead detonated at its calculated aim point in the southwestern perimeter of Saky Air Base. At 2:00 a.m. and 21 seconds, the second ATACMS struck the fuel depot. At 2 a.m. and 34 seconds, 340,000 liters of pre-positioned aviation fuel ignited. A column of black smoke was visible from the port district of Sevastopol at dawn. 47 seconds. Both Pantsir-S2 launch vehicles destroyed. Both 96L6E acquisition radar units mission killed. Mobile command post destroyed. Fuel depot secondary storage destroyed. Replacement cost of all assets $340 million. 3 Russian crew personnel confirmed killed in subsequently intercepted Russian Ministry of Defense damage assessment logs. The crew that had launched the 57E6 interceptors had between 60 and 90 seconds from their launch to the ATACMS impact. In that window, standard Pantsir doctrine calls for immediate vehicle relocation. After firing, you move. You break your radar signature. You deny the enemy a secondary targeting solution and maximize the vehicle's chances of surviving if the first engagement fails. 60 to 90 seconds is not enough time for a tracked military vehicle to reach survivable distance from a 227-kilogram warhead, detonating at its initial position. I spent considerable time reviewing the portions of the Russian MOD damage assessment logs that GUR analysts had obtained and shared with Ukrainian defense officials. There is a single line in those logs, barely a sentence, that references a final radio transmission from the crew of the first system. The transmission was made on an open frequency, not encrypted, not addressed to headquarters command, addressed apparently to each other. The content of that transmission remains classified. What Ukrainian military officials have stated publicly is only that the transmission occurred and that it was made in the 18-second window between the Pantsir crew's confirmed intercept failure and the missile impact. Put yourself in that position for a moment. 3 people. A vehicle that cannot reach safety. An incoming warhead they can track on their own radar, closing at 1,600 meters per second. 18 seconds. And something they needed to say to each other on an open channel that was more important in that moment than any doctrine, any headquarters report, any emergency procedure. The war generates 1,000 moments like this, on both sides of every front line, but this particular one has an unusual quality. These were men whose entire professional purpose was to prevent exactly what was about to happen to them. They had trained for this. They had the radar. They had the missiles. They had launched. And they had failed by 600 meters of intercept, missed distance. And 9 months of targeting work they never knew was happening. The destruction at Saky was confirmed by Ukrainian military intelligence within 2 hours. Satellite imagery, signals analysis, and Berkut's 3:12 a.m. transmission combined to verify all primary objectives. The 19th Missile Brigade targeting cell logged the operation as achieving 100% of planned strike criteria. Then they turned to the next phase. Because the 47 seconds of destruction at Saky was not the operational objective of Operation Dark Corridor, it was the key. Understanding what the key unlocked requires understanding the air defense architecture Russia had built over Crimea since 2014. The Crimean air defense network was not a single layer. It was a carefully tiered architecture designed for redundancy across every altitude band and threat vector. At the strategic level, S-400 Triumph long-range surface-to-air missile systems positioned around Sevastopol and at multiple inland nodes across the peninsula. The S-400 can engage targets at ranges up to 400 kilometers and altitudes up to 30 kilometers. It is optimized for high-altitude threats, including aircraft, cruise missiles flying at medium altitude, and ballistic missiles. Each S-400 battery represents a procurement cost of approximately $500 million. At the medium tier, S-300 batteries, with overlapping coverage at ranges up to 200 kilometers, covering the band below the S-400's optimal engagement altitude. At the terminal tier, Pantsir-S2 systems at individual bases, providing close-in protection specifically against the threat class that the S-400 and S-300 were not designed to handle. Low-altitude threats. Terrain-following cruise missiles, attack helicopters, low-altitude fixed-wing ingress. The critical architectural vulnerability was altitude segmentation. S-400 radar systems, like all ground-based air defenses radars, are subject to line-of-sight limitations at very low altitudes. Below approximately 100 meters above terrain, ground clutter and line-of-sight geometry significantly degrade detection and tracking performance. The S-400 was designed to kill threats flying high and fast, not things flying 80 meters above the ground. The Pantsir-S2 was specifically designed to cover that gap. Its organic radar systems were optimized for the low-altitude engagement band. Its 57 E-6 missiles were designed to intercept cruise missiles, helicopters, and low-flying aircraft in the altitude band below the S-400's effective coverage zone. The Pantsir-S2 at Saky was the only system in the Russian Crimean inventory capable of reliably engaging a terrain-following cruise missile flying the Western Approach Corridor at low altitude. Storm Shadow. The MBDA Storm Shadow is an Anglo-French precision cruise missile with a range of approximately 550 kilometers depending on launch altitude. It uses terrain reference navigation and a low-altitude flight profile, typically 50 to 100 meters above ground level, to minimize radar detection exposure on its approach to target. Its 450-kilogram Broach tandem warhead is designed to penetrate reinforced concrete structures before detonating. Against an active Pantsir-S2 battery at Saky, a Storm Shadow flying the western approach at 80 meters altitude would enter the Pantsir's engagement envelope approximately 45 seconds before reaching its target. 45 seconds is sufficient engagement time for a trained Pantsir crew to detect, track, compute a firing solution, and launch interceptors. With Saky's Pantsir battery destroyed, those 45 seconds of engagement window ceased to exist. The corridor was open. At 4:37 a.m. on September 12, 2023, Ukrainian Air Force assets launched a Storm Shadow package against the Su-30SM aircraft infrastructure at Saky Air Base. The two Su-30SM squadrons based at Saky had by September 12 been partially alerted by the aftermath of the ATACMS strike. Some aircraft had been repositioned to alternative locations. Russian base commanders had partially dispersed their most valuable assets in response to the loss of the perimeter air defense. But the hardened shelter infrastructure, the fuel storage, the munitions handling facilities, and a portion of the aircraft that had not been relocated in time remained at the base. The Storm Shadow package transited the Western Crimean approach corridor at its standard low-altitude profile. No Pantsir engagement, no terminal defense intercept attempt. The missiles reached their targets. The full results of the Storm Shadow mission at Saky on September 12th remain partially classified. Ukrainian military officials have confirmed publicly that the follow-on Storm Shadow mission would not have been operationally feasible without the prior elimination of the Pantsir terminal defense layer. That sentence contains more operational truth than any target damage assessment. The 47-second ATACMS strike did not destroy the Su-30SM aircraft at Saky. It made destroying the Su-30SM aircraft at Saky possible for a different weapon system 3 days later. The ATACMS strike did not directly ground the Western Crimean Su-30SM squadrons, but the corridor it opened, combined with the follow-on Storm Shadow mission, directly changed where those squadrons operated and how far they had to fly to do it. The Su-30SM aircraft that survived the September 12th Storm Shadow mission were not immediately destroyed. They were relocated. Within 4 days of the ATACMS Storm Shadow operation sequence, Ukrainian military intelligence tracked a significant pattern change in Russian Aerospace Forces activity at Crimean bases. Aircraft previously staging from Saky began appearing at bases in Russia's Krasnodar region, across the Kerch Strait, and into mainland Russian territory. The missions were the same. The transit distances were very different, from Saky to the Western Ukrainian operational theater. Approximately 16 minutes from wheels up, from Krasnodar region bases to the same operational theater. Approximately 38 minutes. 22 additional minutes of warning time for Ukrainian air defense systems. 22 minutes that would not have existed if Kravchenko's 9-month window had never opened. Here is what this tells us about how modern precision warfare actually changes an operational theater. The public accounting of ATACMS strikes in the Ukraine conflict consistently focuses on individual engagement results. Target destroyed. Dollar value calculated. Headline written. The cumulative logic of what precision strikes actually accomplish at the operational level rarely makes it into that accounting. The Saky ATACMS strike did not win an air engagement. It changed the geography of the air campaign. What strikes us about Operation Dark Corridor, reviewing all available declassified material and subsequent analysis, is how precisely it was designed not just to destroy equipment, but to destroy an assumption. The Russian air defense architecture over Crimea was built around the assumptions that its layered coverage was robust against precision sequential attack. Each layer would compensate for the loss of any other. The system was self-healing. The Saky targeting cell demonstrated that the system had a single point of catastrophic vulnerability. The terminal defense layer. Remove the terminal defense at any node and the entire sequence of exploitation opportunities opened simultaneously. The S-400 systems could not fill the low-altitude gap. The S-300 systems could not fill it. The A-50U airborne early warning aircraft could not provide terminal defense. Only the Pantsir could. And Pantsir, it turned out, could not stop ATACMS. The doctrinal implications were not lost on the Russian command. The GUR intercepts obtained in the weeks following the September 9th strike include portions of an emergency operational order issued by the Russian command authority responsible for Crimean air defense. Within 48 hours of the Saky strike, the document directed immediate revision to Pantsir deployment doctrine across the entire Crimean theater. The specific changes ordered: Pantsir batteries were to maintain a minimum dispersal distance of 500 meters between individual systems at all times. No clustering of multiple systems within a single terminal defense position, regardless of tactical justification from the local commander. Active radar emission profiles were to be limited to no more than 4 consecutive hours before initiating a mandatory shutdown and relocation sequence. The goal was denying adversary ISR platforms the ability to build a sustained targeting picture of any specific radar position. Mobile command post vehicles were prohibited from positioning within 300 meters of active Pantsir systems. The command post co-location that the Saky targeting package had specifically exploited was directly addressed. Fuel pre-positioning at Pantsir battery positions was prohibited. Refueling would occur only at designated logistics nodes located away from active defense systems. The secondary storage point that the second ATACMS had destroyed was specifically categorized as a vulnerability class to be eliminated across all Crimean installations. Every change was a direct structural response to exactly how the Saky strike had been designed and executed. Here is the take that will generate pushback. The Saky strike is universally described in Western coverage as a Ukrainian operation, and in the specific legal sense, in terms of authorization, execution, and doctrine, it was. But the extent to which it was operationally possible only because of specific and tailored NATO intelligence integration creates a question that Western governments have been deliberately careful not to answer directly. At what point does intelligence partnership in a targeting cycle constitute operational co-participation in a strike? The 57E-6 interceptors launched by the Pantsir crew 31 seconds before impact were attempting to destroy a weapon whose aim point had been calculated using intelligence that was not purely Ukrainian in origin. The specific fragmentation geometry that simultaneously eliminated both 96L6E radar units was derived from sensor data provided through a support relationship officially characterized as advisory. The 9-meter CEP that made the entire targeting solution viable at its designed complexity level was achievable in the Saky context only because of what that ISR package provided. This is not an argument against the support. Ukraine is a sovereign state defending its recognized territory. Crimea is internationally acknowledged as Ukrainian under occupation. The strikes were consistent with applicable international law, but the question of where intelligence partnership ends and operational co-participation begins is one that Western governments, NATO legal staffs, and the scholars advising them are actively navigating in real time. The Saky strike sits near the center of that debate. As Ukrainian targeting precision continues to improve and NATO ISR integration continues to deepen, the line being debated becomes harder to locate. What do you think? Did the level of NATO intelligence integration at Saky cross a line between support and participation? Or does supporting a sovereign state defending its own internationally recognized territory require no further justification? Comment your position. This is a real debate with no clean answer, and we read every serious response. Within 2 weeks of the ATACMS strike, satellite imagery from Maxar and Planet Labs confirmed that the emergency doctrinal order was being implemented. Multiple Crimean bases showed new Pantsir dispersal patterns, systems relocated away from their previous consolidated positions to comply with the 500-meter minimum separation requirement. The operational cost of that dispersal was immediate and quantifiable. Dispersed air defense systems cover less effective territory per system than consolidated ones. When systems are clustered with overlapping coverage zones, the aggregate defended area benefits from mutual support and redundant engagement opportunities. When systems are separated to prevent multiple losses from a single strike, coverage zones separate and gaps appear between them. The radar-to-radar communication requirements increase. The command coordination bandwidth required to manage the battery increases. The logistics footprint required to service separated systems increases. Russian air defense in Crimea after September 2023 was less efficient per system, more expensive to operate, and more demanding on command coordination, with no corresponding reduction in Ukrainian strike capability. By November 2023, GUR analysis had quantified the aggregate operational impact. Sortie rates from Crimean air bases had declined approximately 31% compared to pre-September 2023 levels. The combination of physical damage from both the ATACMS and Storm Shadow strikes, doctrinal disruption from the forced dispersal order, and command-level uncertainty about what other Crimean assets might be under targeting. Development had collectively degraded Russian Aerospace Forces' operational tempo in the Western Crimean theater, 31% reduction in sortie rate from 47 seconds of detonation. The arithmetic keeps accumulating. Russia's response to the demonstrated vulnerability of Pantsir systems to ATACMS involved procurement of S-350 Vityaz medium-range air defense systems for deployment to Crimean bases. The S-350 has anti-ballistic missile engagement capability specifically designed to counter weapons in the ATACMS performance class, a capability the Pantsir-S2 was never designed to have. The procurement cost per S-350 system, approximately $120 million. Satellite imagery obtained in early 2024 confirmed S-350 deployments at multiple Crimean locations previously covered by Pantsir systems. Ukraine spent the munitions cost equivalent of 2 ATACMS missiles. Russia spent over $400 million in emergency defensive procurement in response to what those 2 missiles demonstrated. The exchange ratio in this dimension of the war is not what you see in the headline tallies. The 9-day corridor that the Saky strike opened was only partially utilized before Russia reconstituted its low-altitude coverage over the western Crimean sector. That reconstitution took longer than the targeting cell had planned. They had modeled a 96 to 120-hour doctrinal response time. The actual response time was longer because the combination of physical destruction, mandatory doctrinal revision, and command coordination demands from simultaneous events across multiple Crimean bases created a period of disorganized response that the targeting cell's models had not captured. 9 days. 9 days during which Storm Shadow missions operated over the western Crimean sector without effective Pantsir-class terminal defense. The full scope of what was accomplished during those 9 days remains partially classified. What is known is that the 42nd ATACMS strike at 2:14 a.m. on September 9, 2023 did not mark the end of Russian military capability over Crimea. Russia adapted. Russia spent. Russia revised its doctrine and reorganized its deployment posture. But adaptation and revision are defensive orientations. An adversary that transitions to defense has conceded initiative. The most surprising aspect of the Saky operation, in retrospect, is not the precision. Precision weapons achieve precise effects. That is their purpose. What is surprising is what the targeting cell was actually trying to accomplish. They were not trying to destroy a Pantsir battery. They were trying to force a Russian doctrine revision. They succeeded. The Berkut cell that made the strike possible has not been publicly identified, and will not be. 4 people operating under FSB surveillance conditions in occupied Crimea, transmitting coordinates and vehicle photographs and radar calibration observations across a heavily monitored communication environment for 3 years. They did not fire a missile, they confirmed a coordinate. In the declassified targeting package, their contribution occupies 3 entries in the intelligence sourcing log. That is the proportion in which this kind of work is usually recorded. The 19th Missile Brigade post-strike assessment concluded with the phrase that Ukrainian specialist publications have quoted, but Western media has rarely translated. An adversary that transitions to defense has conceded initiative. 47 seconds, 9 months of targeting work, $340 million. A doctrinal revision issued in panic. $400 million in emergency defensive procurement. A 31% reduction in operational sortie rates. A 60-mile corridor held open for 9 days. The arithmetic of Operation Dark Corridor does not fit on a headline, but it is the arithmetic that matters. There is one element of the Berkut network's operation in the weeks before the Saky strike that we could not fully verify from available declassified sources. Something about the 40-hour silence. Specifically, what prompted the cell to risk the additional observation on September 8th after going dark does not fully resolve from the documentation that has been released. Comment more if you want to see the follow-on video covering the full Berkut operational history in this period. If this kind of granular operational accounting is what you want to see continue, subscribe to Iron Front Ukraine. Every number in this video came from a source. Every name was checked. Every claim is documented. The next video in this series covers the GUR Signals intelligence operation that first identified Saky as a Category 1 target 6 weeks before Kravchenko received his September 1st Maxar imagery. It involves a collection asset that has not been publicly acknowledged in connection with Ukrainian military intelligence operations. The 40-hour Berkut silence was not the only unexplained gap in this timeline. Stay with us.